Hi folks, in this video we're going to look at a technique that can be used with quadratics, which is called completing the square. This is a really useful tool to have for factorising and also for converting from our general form ax squared plus bx plus c into the turning point form, which is easier for graphing. And we will have a video on that following up from this one. Now, the first step you want to do is you want to remind students about how you expand perfect squares. You can either use the FOIL method or you can use a grid, which is similar to what you would have done back when students were first learning long multiplication. So we put x plus 5 here, x plus 5 here, and then we multiply. X by x is x squared. X times 5 is 5x. X times 5 is going to be 5x again. And then the last square here will have 25. And you want students to practice expanding these perfect squares. And what they should work out is that they should go, if we have a plus b all squared, we will get a squared plus 2ab plus b squared. And you can see that's what we've done in our grid over here. We've got x squared plus 5x plus 5x plus 25. If we have a negative in our perfect square like this, we'll get a squared minus 2ab plus b squared. So you want students to recognise these patterns. We're also going to revise doing a difference of perfect squares, which is often abbreviated DOPS. So we're going to revise this. When we expand a, for example, we're going to get x squared plus 4x minus 4x minus 16. And we notice that plus 4x and minus 4x cancel out. We get x squared minus 16. And once we've done that, we should be able to look at all of these other questions and do them straight away. So B will just be x squared minus 81. So here, if we've got a plus b times a minus b, we go to a squared minus b squared. And this is a handy thing to remember because when you see this bit here, a squared minus b squared, we can instantly factorise that problem. Normally when we're factorising, we look for these perfect squares or difference of perfect squares, things which can speed up the process for us. So for example, with these ones here, the first questions are difference of perfect squares. So for example, A is going to be x plus 3, x minus 3. With the second question, it's exactly the same, except first of all, we pull out a common factor. So A, we're able to put a 2 out front, and then we're left with x squared minus minus 16, which is a difference of perfect squares problem. So we go 2x plus 4, x minus 4. Now we're going to look at some perfect squares and factorise them. We look at this. This one here is going to be x minus 2 all squared. We think back to that formula that we had several slides ago, where we had, if we've got a minus b all squared equals a squared minus 2ab plus b squared. The second question here, b, it's going to be x plus 3 all squared. So for this we would look at our formula for a plus b all squared. A squared plus 2ab plus b squared. C, we look and we go, this one here is a square number, and the square root of that times 2 is 12 here. It is also going to be a perfect square. So we've got x plus 6 all squared. What we're going to do now is we're going to apply this to questions which are not immediately obvious as a perfect square. And by doing that, we're going to rearrange our general form here, y equals ax squared plus bx plus c, and we're going to rearrange it into this form here, which is often referred to as the vertex or turning point form. The vertex is just the turning point, the point of the graph here, for example. The useful thing about the vertex form is that it is very easy to graph. Now, when we look at it like this, what we can see is that part of it is really a perfect square, isn't it? X minus h, all squared. That part there is a perfect square. So what we are going to do is we're going to learn a technique to go from general form to turning point form. So let's start off with x squared plus 8x. When we look at it, we notice that it is like part of a perfect square. To make it into a perfect square, we would have to add 16. And then it could be x plus 4 all squared. So what we're going to do is we are going to add that 16 in to make it so we can write it as a perfect square. But we can't just put 16 in out of nowhere. To balance that, we have to do a minus 16. So this is like we are effectively adding 0. We're adding 16, we're doing minus 16. Let's then put brackets around it like this to separate out our sections. We can see that this section here, this is going to form our perfect square, x plus 4 all squared. And we are left with the minus 16 here. And see, we have now put this into turning point form. You will sometimes see completing the square written like this. And this is just showing us what we have done in a different manner. So what this is that this section here is the part that we need to add in to complete the square. It is our b, whatever this is here. We're going to divide it by 2, and then we are going to square it. So that is what we have up here. And then, because we have added something, we have to subtract it there. Now, something you will notice is that when we have got to this format here, this is effectively a squared minus b squared. So we could now factorise this using our difference of perfect squares. A plus b, a minus b. Let's practice that a little bit. So what we're doing is we are working out what do we have to add in to complete the square. So the first one, we've got x squared plus 10x. To complete the square, we divide our 10 by 2, so we've got 5, and we square it. So we have to add 25, and then we subtract the same 25. We'll put brackets around that to make it really clear that now we're going to have x plus 5 all squared minus 25. If we look at question C here, we've got x squared minus 4x. To complete our square, we're going to have that minus 4. We divide it by 2, 2 minus 2, and then we square it. So we'll get plus 4, and then we have to do a minus 4. So we're going to have x minus 2 all squared minus 4. Let's practice one more. X squared plus 16x down here. Half of 16 is 8, and we square it to get 64. So we add 64 to complete the square. We take it away. We'll put our brackets here to make it really clear what we're doing. We do x plus 8 all squared minus 64. Now, what is more common is we will have something with a constant out the end here. So this is our format, ax squared plus bx plus c. The easiest way to do this is to actually just move our constant out of the way over here. Don't forget about it. We're just going to put it to the side. Now we have x squared plus 8x. We know how to complete the square for this. It's going to be x squared plus 8x. We'll have to add 16 and then subtract 16. Now let's put our brackets in here to rearrange it. So it's very obvious which part is going to form our perfect square here. This will be our x plus 4 all squared. The constants are left over here. We've got minus 16 and plus 2. So that goes to minus 14. If we wanted to, we could then use our dots to factorise it. A squared minus b squared. And this is a really useful tool. Let's practice that a bit. So we start off by moving that constant, that's 7, over to the side here. What do we need to add to complete the square for this bit here? We're going to need to add 4. So then we have to subtract the 4. This part in here is going to form our perfect square. So it will be x minus 2 all squared. And we have minus 11 left over from this section here with our constants. Let's practice again. So we've got for b, x squared plus 2x. Let's put that minus 2 over to the side. To complete this square, this part here, we're going to have to add a 1. So then we subtract a 1. Put our brackets in here. So we're going to have x plus 1 all squared minus 3. Let's practice 1 or 2 more. We write it out underneath, but we move our constant out to the side. We work out what we need to add to complete this square. We minus 14 divided by 2 is 7. We square that, so that will be plus 49 minus 49. And then this part here is going to form a perfect square. X minus 7 all squared. And we're going to be left with negative 49 plus 43. So that would be minus 6. One more. We've got x squared plus 8x plus 9. Put that 9 over to the side. And we're going to have to add half of 8 is 4. We square it to make 16. So plus 16 minus 16. And we're going to get x plus 4 all squared. And we are left with our constants here, minus 16 plus 9. So that will be minus 7. If we do this, x squared minus x minus 1. To complete this square, we're going to have 1 divided by 2. So that will be a half. And then we have to square that. So it will be plus 1/4 minus 1/4. So our perfect square here is not going to be as nice. It will be x minus a half all squared. And then we will have here negative 5/4. And I'm going to write it in this format because it's just a bit easier, especially if we then use our dots to factorise it. So if we did that, we would have x minus a half plus the square root of 5 on 4. And if we remember our surds, we go, that's the same as the square root of 5 on the square root of 4, which means that we could say it's just root 5 on 2. And then we would have for our second part of it, x minus a half minus square root of 5 on 2. As you can see, this enables us to convert to our vertex form and to factorize, and it's just a helpful thing to have in your toolbox of techniques. Sometimes we can factorize by observation, sometimes we use the quadratic formula, sometimes this is going to be the easiest method. What I will do in the next video is I'll show you how the vertex form makes for easy graphing. Thank you very much.